Aldol condensation. Aldehydes having alpha hydrogens undergo self condensation in the presence of mild base to give beta hydroxyaldehyde. I am giving you an example of aldehyde molecule carrying alpha hydrogen. As we know, acetaldehyde molecule like the carbon atom which is directly attached to this carbonyl group is called alpha carbon atom, and the hydrogens which are directly attached to this alpha carbon is called alpha hydrogens. So here we are having three alpha hydrogens. On the other hand, benzaldehyde molecule carries no alpha hydrogen. As you can see here, the carbon atom which is directly attached to this carbonyl group carrying no alpha hydrogens, and that's why it is not capable of showing aldol condensation reaction. Now let's see the mechanism of aldol condensation reaction. It includes three steps. The first step involves formation of enolate anion. In the presence of mild base hydroxide anion, one of the aldehyde molecule carrying alpha hydrogen undergoes electron displacement effect. Oxygen, being highly electronegative in nature, attract the double bonded shared pair of electrons towards itself and making this carbon positively charged. As a result of this carbon will attract the pair of electrons which is shared between two carbon atoms towards itself, and thereby this carbon atom attract the shared pair of electrons between carbon and hydrogen and making this hydrogen positively charged. So for hydroxide anion, now it becomes very easier to abstract this hydrogen to form H2O molecule with the formation of enolate anion. This enolate anion is resonance stabilized molecule, and stabilized to form a double bond between carbonyl carbon and CH2 group. In the second step, this enolate anion attack on the second molecule of aldehyde which is carrying alpha hydrogen. As I have told you that oxygen, being highly electronegative in nature, it will attract the double bonded shared pair of electrons towards itself and making this carbon positively charged. So this negatively charged anion in the enolate anion easily attack over this positively charged carbon atom to form an alkoxide ion. This is called alkoxide ion. This alkoxide ion is responsible to give the final product in step 3, formation of beta hydroxyaldehyde. So this alkoxide ion abstract proton from the solvent molecule because it is highly negatively charged and easily abstract the proton from the solvent molecule by regenerating hydroxide anion to give the final product which is called beta hydroxyaldehyde.